All right. Let's see how long it's going to take us. So, good morning, everybody. I am Efthymis Sarbanis, and I will be talking today about taking the bus in Flutter apps. Well, the bus in our case is an event bus. So, just create Flutter, reactive Flutter apps using the event bus. So about me, I'm currently the CTO of OneRoof. You can find us at OneRoofApp.com. We are a hyperlocal community builder for large buildings in urban areas and not only. And we are facilitating the intercommunication and building healthy communities. I have like more than 15 years by now experience in the field, not in Flutter, of course. Flutter is a lot less, but I think Flutter is the last 3 years. As Evgeny was kind enough to mention, I'm co-organizing Flutter Creek community. You can find us at meetup.com/fluttergr. And I have also published a couple of libraries under the group of Flutterings. There are a couple of them. There were some patterns that I just externalized them into libraries. If you can go there and see if something is something that you want to use. I am a GD for Dart and Flutter. And I guess that's it about me. And we can go on. So I have a disclaimer here. And I have this disclaimer either verbally or written in all of my talks. It's like if it's an architectural paradigm, look, all architectural paradigms are biased in a bit, right? Because they are there for solving a certain part of a problem or like a certain set of problems. It's not there to solve every problem in all domains. So whatever I'm going to present to you here is not like the medicine for all, a treatment for every illness. Is just an opinion, something that I saw that it was nice and felt nice to me. So I wanted to present. Maybe other people might find it interesting to pursue. So what is an event bus? So an event bus is a pattern, an architectural pattern, and it derived from the early days of service-oriented architecture, or SOA, which was like back in like a decade or so was the thing. And the event bus is actually a glorified pub sub queue or pub sub kind of bridge. So what it does is like a component can send an event to the event bus, but also a component can listen to events in the event bus. And it's called the event bus because it's kind of like a bus line for events. So an event like gets into the event bus in one point and might get out in multiple points. So what we have here is the event. We have a component that can send an event to the event bus, and maybe multiple components can listen to that event so they can react to it. For example, one of such event could be like a user has signed in, right? So that's an event, something that happened and is sent to the event bus. And when a user signed in, maybe certain things have to happen. Maybe we have to cache their token, or we have to do like a navigation, or any of that. In our world, in the backend world, it's kind of right now it's used in microservices and in domain-driven design kind of systems. It's very crucial, but it has like in the backend, it has its drawbacks because it's very complex. It's like that kind of decentralize the whole thing. It's very complex to debug, very complex to find what's going on. There are patterns that you can use to actually do those things, but it kind of overcomplicates things if you have something simple. So event bus in Flutter. So that's a question mark. Why do we might need an event bus in Flutter? The thing is that in Flutter apps, it's an inspiration of how the operating systems use events in their UI. So a UI in a screen, let's say in the operating system, Linux or Windows, whenever something is done on the screen, it emits an event, and then the operating system can catch this event and respond to it, or your system can catch that event and respond to it. And that's very powerful because you can decouple your front end, like your UI, from all of your service and your logic. And I was thinking that would be like a nice thing sorry, to have in Flutter. And actually, there is a library that I am using, which is called the Event Bus 2.0. And actually, that library is very simple. If we go to that library and we go to the code, just bear with me. So it's this file of 69 lines. Oh, it's less if you just count out comments and all that. It's a very, very concise thing. And it's very easy to, it uses streams and stream controller to get events and get subscribers to events. So that's very, very nice. Another thing, let me see if I can maybe, yeah. All right. So I have to go back. Okay, it hit the font pretty quickly. I'm sorry about that. All right, so let's see here. And slideshow. All right, now we're back in. So sorry about that. I just want to show you how easy it is, like how simple that library is. It's just like a glorified Pubs app inside your app. And because it uses Stream, it doesn't have any dependency in any other library. It's really lightweight and easy to use inside your app. It's kind of like a sugar coating around the Stream controller. Basically, so where can you use like an event bus? That's like the first question that comes to mind is how can I use an event bus? What's the benefit of it? So if you combine the event bus with a Navigator 2.0, so for those of you who don't know, this is not the talk of Navigator 2.0, but very briefly, I want to say that Navigator 1 is uses an implicit navigation style, which means that you tell them where you want to go. But Navigation 2.0 is the Navigation 1 is an explicit navigation style. And when you tell it where you want to go, and Navigation 2.0 is an implicit style, which means that it responds to a certain state. So when you change something in your app, then the Navigator will take that change, will evaluate it and see if it needs to do something with the page history list. And if it does, then it creates a new page history. And that's how you navigate with Navigator 2.0. So if you match like the implicit way of Navigator 2.0 and the event bus, then you can like match them together and say, okay, the event bus like carries events. So the Navigator, like the app navigation delegate, can actually subscribe to events in certain events in the bus, and tell the router like rebuild the page history according to the event. So let's say that an event like a user signed in event comes here. Then the app navigator delegate will listen to that event, and whenever that comes in, said, oh, okay, so the user has signed in. So I need to display my first screen after signed in screen. So I will create a list of pages which has only one page, which is like the welcome screen, because I don't want the user to go back to the login. Very briefly. But because you can hook up the navigation delegate to the bus, you can also use like the deep linking. So deep linking, what's deep linking is whenever, let's say, you have a push notification come to your device, and then you tap on it, and you want it to open up, let's say there's a chat app, right? And there is a new message. So if you want to tap on it, and the app will open, and it will open to that message, but you would want to have the opportunity to go back if needed. So back to the, let's say, channel list. So the deep linking service, what it can do, which uses unilinks, it's another library. When the app opens, it checks to see if there is a something that is a deep link, and if it's a deep link, then it sends the appropriate events to the bus so that the navigator will adjust the history of the pages so that the navigation is going to happen and all the history is in the right order. So that's like a theoretical, in order to show that in code would be very complex and very time consuming. So I'm just going to have like a layout. We will have a demo, but a very simple demo so that you can see how you can use it and how you can get some value out of it. So the emitting, I'm sorry. So the emitting of the events. I am using Gedit to wire up all of my services. So that's why I have like this locator is the Gedit locator. So I register a singleton, which is the event bus, and that's it. After that, so that's the very first thing that I register to the locator to get it. After that, all the services that uses the event bus can be registered after that, and it will be sure they will make sure that the event bus is going to be there. Then we can create an event emitter as a mixin, and you want it to be a mixin so that it can be used in whatever object you want. Right now, we're going to keep it simple, but you see this emit function. This emit function uses the locator. This is not a good way. Like I don't want to tuck away this implementation details, which means that the event emitter has a dependency on event bus. But because I want this emit to be just called on the event itself, I just water my wine, as we say in Greece, and I put this locator here. So I get the event bus and I fire this. So the event emitter is actually an event. How is that so? We create an abstract class called event that has an event emitter. And how would that lead us to events? So let's say that we have a user authenticated event, which extends a token-aware event, because that's a token-aware event is an event that actually carries a token. But because we have multiple of those events, we cannot have that abstraction. And let's say that the token-aware event extends the event, which also has this emit. So what I can do is, in order to use it, is I can say user authenticated, put the user in, put the token in, and then .emit. And this will emit itself to the event bus. And this is very powerful because all you need to do in your UI is to have access to those events. And let's say like the login screen needs to have access to the user authenticated event. And when the user is authenticated, then the user authenticated event .emit, and this will emit the event to the bus. It's kind of like magical. That's why I wanted to have this implementation detail behind the emit not showing. So that's the emitting. So that's how you can create an event and emit it. But how can you listen to it? So listening is quite easy. So what we have is an event-aware mixin. This event-aware mixin gets the locator again for the same thing, because I want to have this listen method and I want to hide away the event bus dependency. So when I say to the locator, when you get an event, if you remember back, we have a type event. So when we get this event, listen, and when you listen, just get this event. So here, right here, I have server and client event. Let me tell you a bit about that. So let's say that you have like a chat app. A chatting app actually listens, opens usually a WebSocket or a connection to the server that listens to events coming in. Those kind of events comes from the server, so they are server-side events. Let's say that you have a new message coming up in one of your channels, and you want to update the unread counter of the channel if you are in the chat list. So when you're there, the event comes in, and then whoever listens to that event will get the event. And so on server client event, we'll implement this method on server client event, and it will get this event and respond to it. We'll have an example, and not for server events, that's quite complicated, but for client events, let's see now. Observing, that's one of the powerful things that you can do with such an architecture in the event bus. You can create an event observer. So what's an event observer? An event observer has a listen event, a listen method, which also listens to the events, but listens to all events. Doesn't care if it's a server-side or a client-side event. Client-side events are events that are emitted by the UI or by other services. Server-side events, these events are coming from the server. So we have this observer, which is an abstract class. Let's say that I want to log every single event my app emits. Then I extend this event observer, and I override the observe method. And let's say I get like the event name out of the runtime type, and then I log it and line up bring it. But let's imagine that you have something like an analytics service, right? You have Segment, or you have Google Analytics or Firebase Analytics. You can hook, like you can create an observer, and you can have a dependency to that analytics service, like maybe a Segment, and you get the event, and then you log that, if you send that event directly to Segment. So now, out of the box, without doing anything much, and without like injecting little pieces of code around all of your code base just to emit an event whenever you know something happening, you just listen to the event bus. And because you know that everything that happens goes through the event bus, you know that you can get all the events, everything that's happening, and send it to Segment. And that's like or analytics. So that will give you a lot of power in your analytics capability on your app. See, like, you know, what buttons is pressed a lot, what chat rooms are the most popular, or, you know, who is the one that's posting the most messages. Like, you can have a lot of insights out of that. So coding, let me see. I have, let's have a coding example just so that you can see what's going on. So right now I have opened my emulator, and I am here. Let's create like a new Flutter project. And let's call it Dart App 21. All right, CD to that project and open the Visual Code. And here it is. Let me just hook it there. I don't know if it's big enough for you. Let me just have it like that. Maybe that's better. Hook it there. So let's see how. So everybody's familiar with the out-of-the-box app that Flutter creates, right? It's the counter app. So in the counter app, while it's loading in the emulator, I'm just going to say a couple of words for those of you that might not know it. The counter app is just you have a counter in the middle of the screen, which is the number of times you press a button, which is in the lower right of the screen. And lo and behold, this is it. So you just click on it, and it's open, and it increments that. So let's see how we can do that, being more responsive. And I have prepared a bit of code just so that you don't watch me implement like everything. So I will create a new file. I will call it event start. And before all of that, let me just open the terminal and add two dependencies. So other add, we need the event bus, of course, right? Because otherwise this talk has no meaning. And we also want get it. That's because I'm familiar with it. I mean, nothing to it. Okay, so we have those two, right? So let's see what we can do. And first of all, let's create a getter to get the get-it instance as the locator. And I do this just out of convenience, so I don't like write this every time. Let's have a method to set up the get it, so we can have locator, register singleton, and register the event bus. Of course, this doesn't know what the event bus is, so let me just pull it in. So we have this setup. Okay, so we go here in the main and we put a setup just to wire up everything. So now we have wired up our event bus. So I will just copy and paste the code that I have already showed you in the slides so that you don't see me type everything. So this is the event emitter, right? And so it does what I told you it's going to do. It gets from the locator the event bus and fires this event, and we have this type of event, right? And let's also have the listening part. I'm putting everything in the same file, just so that I don't create every file here and there. Just open this up, maybe would be better. All right, so this is the listener. This is exactly the code that I showed you in the slides. So if you want to go over it, but basically there's no server-side event here because it's just simple, just one event, just to showcase. Save it and reload it, and then I can do like the observing code. Right, so that's the observer. So now we have set up all that we needed in order to have the event bus into our app. So how can we have the event bus in our app? Basically, if we go here, we see that what this does is that it has this state, and it sets the state when it's incrementing, right? So we need to replicate that into a service. So let's create a service that will have a counter, and let's say that's the counter service. Okay. And this, of course, is the counter service. Now, this will extend the value notifier. This. And have the import. Well, actually, let's do right. Widget is more general than Cupertino or Material. That's why I put it there. It's our service after all, so we don't really need anything from the other libraries. So we can create the call to the super, and we initialize it with 0. So our initial value is 0. So let's try to hook this up to this. In order to do that, we have to wire it up into get it. So we have to wire it up into our locator. So basically, with a bit of copy and pasting and counter service, this is done. So I have an error. Oh yeah, because I passed the value, but I don't need to pass the value because I know the initial value. Let me just move that. So here we have it. And because it's hooked up there, I know that my service gets it. So let's see if it really gets it. So I'm going to remove the state here, and I'm also going to remove this method because we're going to emit an event for it, and we don't need this method. So this is the counter. So I'm going to wrap that into a builder, which is actually a value listenable builder. And this value listenable builder listens to a value listenable, which with our locator, we can have the counter service there. Right? And here, what I need is this is the counter, and we also get a child that we're not going to use. So here, that's it. And if I save, okay, so this is something that we're going to replace in a bit. So let me just save that. So here we see, let me refresh, and it's 0, and it's not going to do anything because we haven't hooked it up with an event. So let's do that. Let's hook it up into an event. So because we have extended value notifier, we cannot extend anything else. So if we go, I'm sorry, if we go to the listener, we cannot extend the event listener class, but we can use the event aware mixing, and that's the reason why we have it as a mixing, because you can use it in the in your service, or you can even use it in your widgets if you like to. But right now we're going to use it in our service as a mixing. So let's go with event aware. All right, so let's override. Let's override the how do you call it? So the event aware, the listen method. So we have to put this listen into our constructor and then override the on event. So let's do that. Let's put like listen in here, and we don't need that. And let's override event. So we need to create an event type in order to do that. So what we want, we're going to go here to a meeting and say, all right, I'm going to create a new event. I'm going to say like it's counter increment it, right? And this like actually extends the event class, right? And I don't need anything in it. We can put like state here. So if we wanted to pass something along with this event, we could like put it in a variable inside here, like final, I don't know, like int value. And we can have that in the constructor, and that's totally fine to do that. But actually, we actually know what to do. It's an increment. So we will say, hey, increment your state. Right. So counter increment. And now what we want to do is here to see if the event is a counter increment event, then our value, which is the counter, sorry, add 1 to our value. Oh yeah, it's supposed to be async as well, and it's async just so that we can facilitate any asynchronous code that we needed. Right now we don't need any, but we should put it like that. Okay, so we have the service, and this service should listen to that event, right? But we don't emit an event, like we still don't emit an event. So let's go and see how we can do that. So remember this one, we can remove that and say whenever you press a button, like emit the counter increment event. Sorry, that should be an instance, and that should be an emit. All right. So whenever you press it, you emit. So if I press this, nothing's happening. Why nothing is happening? The thing is, let's go. We have registered both things. We have to hold because we want to register again. Because remember, when we first registered, this was not an event aware. Now it is an event aware, so we have to rerun the setup. So now when I hit it, you see the event is emitted. The counter service gets the event, sees that it's a counter increment. It adds the value, and here, because we have a listenable and we say, hey, listen to that value, it gets incremented every time. But okay, so remember the observer. Let's see how we can utilize the observer, and in order to also print that event in every time. So let's see. We have some time. Well, actually, let me just copy paste the code. It's easier if I just write and you come along with me, but kind of hard to find. So we have this logging event observer, right? We have to register it to the locator as well, right? Register singleton, and that is, well, not that, but is the logging observer. Save it, hot rerun, because we want to set up to run again. All right, so let's see what happens. I'm in the debug console. See, it gets every single event and it prints it out. So imagine that we could have like a connection, like a dependency to Firebase Analytics. We could send that event to Firebase Analytics every time someone clicks on it. And that's like out of the box. We just created that. We said, okay, observe the events, and whatever event you want, like do something with it. And we registered with our locator, and that's it. Nothing more. We don't need anything more. But how about tests? So tests are kind of neglected, right? And right now, if I do like flutter test, let me just pull it up so you can see. So it runs a test and we have a failure. And of course, we have a failure. If we go to the test, let's pull it down a bit now. And like close everything and just open up the test. So test is just like what's doing. It's pumping up my app, checks the initial state, which is okay. But when we tap by icon, it taps the ad, nothing happens. And the thing is, because we have created some dependencies, we need to set this dependency up in our tests. So let me just copy paste some code here, and I will walk you through how we can make this test run. So we have like a test event bus. So in this test, in the scope of this test, we initialize a test event. Here it is. We set it up, and we register it into our locator, because the locator then is going to it's the get it, and it's like a singleton, and it's like a global state. So the test app will see that. So if I run it again, we have a failure, of course, because we need some additional okay, let me see. Flutter test. Okay, we need these imports. For some reason, my ID does not show that kind of compilation failures, but anyway, you know what it is. All right. So why? It doesn't see my app. Okay. Just of course, I have copy pasted from a different. Well, that's not Flutter test. That's what we call it. We call data. Up 2021, and that's the one that we're gonna put here and here. Right? For some reason, I don't know, compilation fails in testing my ID. So, okay, so we have made this test pass just because we have wired everything together that my app needs in order to do. How can, so the other, one of the benefits of the test-driven app, not the test-driven, the event-driven like application is that it's more testable. Let's see how we can test. Because I don't have enough time, I'm just going to copy paste some code, and like copy pasting, I guess it's the new way of programming. I don't want to type all of these. I'm just going to run through you. Let me just close that off so that we can have more, like have everything in the screen. All right, now I have everything in the screen. So this test says that when the counter increments, we should emit an event. It should emit a counter incremented event. In order to do that, we listen to the test event bus. Remember the test event bus we have set up here? So we listen to it. And we say whenever a counter event whenever you listen to a counter incremented event, just get the list of all the events that you have listened to and put it here. And that's a future action. So the test is pretty much simple. So we pump the widget again. We also verify the starting state. It's exactly the same as we do up above. And we test, we tap the icon to add, and we pump. But then we don't do this verification, but actually we want to see if this event emitted, if this component emitted this event. So what we do is that we destroy the test event bus, meaning that there's no more events. So just close it off, and that's it. So now we have this event list where we await. Otherwise, we would wait forever, right? Because this is keep listening as long as this event is open. So we destroy it. We await it, and we get all the events. We say, okay, this is the events that I get is one event. I get the first event, and the first event is a counter incremented. Let's run this test and see if it passes. So it passes both tests, and that's great. So that's about it for the demo. Let me go to the slides. And yes, all right, we're done with coding. So before I close off, there are some pros that I want to. So I wanted to showcase, how you can do it and how you can create like test really simply by using a test event bus. And so the pros are that it simplifies the communication between the components. So let's say that a service needs to be aware whenever a user is authenticated, but you want to split that service because it has like different interests than like the whole service. So you don't want to put that service or that logic inside the service that's handling the login or the authentication. So whenever you do that, you have a service that's only concerned about the authentication. And whenever a user is authenticated, it emits this event. Other services that, let's say, cache a token or something like that, could listen to the user authenticated event, or even the delegate for the navigator will listen to this event, the authenticated, and will do, it will alter their state, and everything's going to be like up to sync. So it's kind of simplified. Just emit an event, listen to this event, and you're done. It decouples the senders and the receivers. So the senders, like the majority of the senders, is the UI component. So it's like the widgets. So the widgets will emit events. And then you can have like wire up. If you test the widget, then you can test and see if the event is emitted in a certain way, right? So you just test the actions and see, okay, when I click that, and that, I want like those three events in certain order to appear. And the testing is easier. So it avoids like injecting services or injecting components that are complex inside your widgets, which might have different reactions to the life cycle. So let's say that you have a stateful widget and you have like certain things being done in the init state. But you know that this service needs to like react to other things as well. And those other things may come from the UI, but the init state is only going to run once in the life cycle of the widget. Then it's a kind of like complex thing to solve. But if you decouple that and you have your service or your like logic component to listen to an event that the widget is emitting, then the widget could emit this event inside the init state, and could also emit another event in the actions that it have. and it makes you testing the UI easier. So the cons, it adds a bit of complexity, let's be honest. Like you have events going inside this event bus all the time, and you need to listen to it. And this, like in the third point, makes it hard to debug. So if you have a problem, you have to see like where the flow of the events went. So it also might need some orchestration. So certain events need to be emitted before other events, or certain services need to be registered before other services, just because it emits an event whenever you register it, and then the other service need to listen to this event. So it kind of like complicates things in a very big app. But if you decouple it a lot and you introduce a lot of events, then you can kind of ease it out. And that's about it. I think like have 4 minutes to spare, I guess. Oh, Evgeny, I cannot hear you. I think you're muted.
Yeah, days without microphone muted, 0.
Yeah.
Thank you very much for your talk. It was a really nice talk. And please, if you have any questions, post them in chat, and we will ask them. Or if you want to ask them in personal, join a special chat. I have one question that sometimes some people, in some architectural patterns overviews, event bus told to be a bit, I would say, more on a more complicated side, and probably it has some problems. First of all, with scalability. Do you feel so that if, for example, your application will grow and events, there would be hundreds of events, it will be unscalable?
Yeah. So let's say for a case study, we have like 100 events per minute. It's not that possible, because the events are emitted from the UI, and the UI is interacting with the user, right? So the user is actually the one that's doing the event. So your throughput, your threshold is the user's threshold, which is a human. So it's not possible to emit like a lot of events, like user-generated events, right? On the other side, if you have on the server side events, you might want to be more careful of how you can tackle that. So on the server side events, what I do, but it was a bit complicated, I didn't show it here. So what I do in the user side, in the server side events, is that I have a service that listens to those events from the WebSocket, right? Or from whatever service you use. You might use Pusher, or you might use, whatever you use. So it listens to those events, and the logic of if these events needs to be emitted in the batch is there. So it kind of like throttles and also filters the events before they enter in the event bus, and then all the reactions happen.
I see. And
in the backend, sorry, just in the backend, yes, it might be a problem of scalability. It might be a problem of you have like a single point of failure, like if the event bus is down, like you have no system, right? So you have to be very, very careful in your infrastructure in the backend. But in the front end, it's very simple. As I showed you, it's like 60 lines of code, and it's all based on stream controller, and it's in memory, and it's like very lightweight. It's I mean, it all depends on the amount of events that go through the event bus. And if the majority of those events are user-generated, your throughput is directly associated with the throughput of the user.
So user cannot generate 100 events per second.
I guess if you have a game that needs to to tap like crazy, I guess you can generate a lot of events. But in gaming, you have other architecture that I'm not aware of. So I maybe this is not a good architecture for games. But also, again, and my disclaimer, I want to just stress it out one more time. This was a very interesting project that I gained a lot of knowledge, and I gained like some insight, and I want to share. So it's not like the something that solves all of your problems, but much so solves some problems. So for navigation and for like deep linking, I found it very, very useful.
Mhm. And we actually have an adding question from Georgi. Any reason you would use event bus instead of block on medium to large projects, other than letters complicity? So probably
Yeah.
you already answered, or
Yeah. So no. So again, it's not like either or. You can use block and you can use the event bus as well, right? So if the event bus is kind of global to the app, the block is kind of like more localized, right? So you could have a block listening to events in the event bus from other blocks that do other things. So you kind of like merging, like connecting two blocks together or something like that. But mainly event bus is kind of like app wide, and the block pattern generally is more localized to a certain part or certain widget.
I see. Yeah, and I totally agree that you can use uh, any combination of any patterns. You can use block
Yeah.
with sometimes you can use it block with redux. I've seen this, but yeah,
I
figure out.
I have written an article about it actually. How you could
Hmm.
use block with Redux.
Nice, nice. Would you recommend this?
Uh, it was um, it was an experiment I did, and I saw that it worked. So if you really want the global state of block of
Mhm.
Redux, but you really want the reactivity of block into your components, you can use the two.
Yeah, yeah. Okay, looks like we don't have much time for